Hi everyone, in this video we will have a look at angles and triangles, we'll have a look at quadrilaterals and polygons as well. So we will classify triangles based on two qualities. The first is based on angles and the second is based on side length. So if we quickly have a look at triangles based on angles, we have three. The first is an acute triangle. Now, an acute triangle is where all the angles are acute. So all angles are acute, meaning they are less than 90 degrees. Our second type of triangle based on angles is an obtuse triangle. Now, with an obtuse triangle, we only have one angle that is obtuse. So that angle over here is an obtuse angle. The rest are acute. So an obtuse angle is one that is greater than 90 degrees, but less than 180 degrees. Our third type of triangle based on angles is a right angle triangle. Now, a right angle is exactly 90 degrees and it can be represented with a square. So this angle over here is called a right angle. Alright, so these three types of triangles were based on angles. The following three types of triangles are based on side length. So the first is scalene. So this is where all three sides are different. So three different sides. And this could be represented by lines. So one line means that this side length is 1, this side length is 2, and this side is 3, meaning that they're all different. The second type of triangle based on side length is an isosceles. So this is when we have two equal sides. So the two lines mean that those sides are equal, and the one line means that that side is different. Now, the angles are also the same. So in an isosceles triangle, the two sides are the same and the two corner angles are also the same. And the third type of triangle based on side length is an equilateral triangle. This is when all three sides are equal. Over here, I'm going to just represent these with the line. Since all three sides are equal, all three angles are also equal. So there's 6 types of triangles, 3 based on angles and 3 based on side length. Next, we have the interior of a triangle. Now, the interior of a triangle means that all the angles in a triangle add up to 180 degrees. So angles in a triangle sum to 180 degrees. So if I have two parallel lines, and we had a look at this in the previous video, and this is my triangle over here. That's going to be A degrees, this is going to be B degrees, and this is going to be C degrees. I can form a Z over here. Now if I form that Z, I know that since here is A, over here we're going to have A. I could also form a Z over here, meaning that over here I have C degrees, and since a straight line equals to 180 degrees, A plus B plus C equal 180 degrees, which also happens to be all the angles within a triangle. Have a look at the exterior of a triangle. Now the exterior of a triangle, let's draw a triangle over here, and this is a straight line, 180 degrees. let's have A degrees, B degrees, and C degrees. So the rule says that the exterior is the opposite to side lengths, so A degrees plus B degrees. And based on the sum of the angles in a triangle where it sums up to 180 degrees, we know that A plus B plus C equal 180 degrees. So if I want to find C, I could do 180 degrees minus A degrees minus B degrees. And since the straight line over here, I have a straight line there, I know that if I want to find the exterior, so this section over here, all I have to do is I have to do 180 degrees minus C degrees, and I can then rewrite that as 180 degrees minus A degrees minus B degrees. So that's an exterior of a triangle. Let's have a look at a quick example over here. So let's say I had this triangle over here, that was 85 degrees, this is X, and over here I have 150 degrees. I want to find what X is. Well, I know that X plus 85 will equal to 150 degrees. Remember, it equals the exterior. Well, if I want to find X, do 150 degrees minus 85 degrees, and X degrees gives me 65 degrees. Over here, that's 65. Alright, let's have a look at quadrilaterals. Now, a quadrilateral is a shape with, we went to write with a pen, not a highlighter. It's a shape with 4 enclosed sides. And it also has 4 angles, therefore. So we have a parallelogram, we have a rectangle, square, kite, trapezium, and a rhombus. So these are all types of quadrilaterals. And the rule says that the angles in any quadrilateral, regardless of which of these we're looking at, any quadrilateral, sum to 360 degrees. So a triangle sums to 180, a quadrilateral sums to 360. Let's have a look at a quick example. So let's say I have this quadrilateral over here. So this is 8 degrees, this is 50 degrees, let's say this is 120 degrees, and that's 80 degrees. I want to find A, so I know that A plus 50 plus 120 plus 80 degrees equals to 360 degrees. So once I add all these up, that gives me 250. So I want to find A, so I'll do 360 degrees minus 250 degrees. Therefore, A degrees is 110 degrees. Although the illustration really doesn't seem like it's 110 degrees, that is the working out. All right, let's quickly have a look at polygons. Now, there's 2 types of polygons we're having a look at. We're looking at any polygon, and we're also looking at a regular polygon. So the difference is a regular polygon is a polygon where all side lengths are equal. So the rule of any polygon says that the sum of the angles is 180 minus, in brackets, sorry, n minus 2, where n is the number of sides. So this rule applies to any polygon. So if I want to find the sum of the angles, I do 180 times n minus 2, where n is the number of sides. Okay, now with a regular polygon, again, the same rule applies, but over here we're moving a step forward, because all the side lengths are the same, we can actually find a single angle. And that is a single angle, a single interior angle is 180, again, n minus 2, and we're dividing it by n because there's n angles. N side lengths meaning there's n angles as well. So where n is the number of sides and also number of angles as well. Put that in a bracket. So that finds a single. So the previous example finds the sum of all the angles, whereas this one finds a single. But this only applies to a regular polygon, and a regular polygon is a polygon where all side lengths are equal. Okay, let's have a look at a couple of examples. So the very first example over here, I have 95 degrees here, 170 degrees over here, 100 degrees here, I have 2x degrees here and 55 degrees over here. So step 1 is I need to find n. So remember n was total number of sides. I'm just going to put lines. So that's 1, 2, 3, 4, and that's 5. So n equals 5. Step 2 is to use my rule. I want to use 180 n minus 2. Where n is 5, so I have 180, 5 minus 2, that's 180 times 3, and that gives me 540 degrees. So that is the sum of all the angles, but I want to find what x is, remember. So to find x, I need to add all my side lengths. So I have 95 degrees plus 170 degrees plus 100 degrees plus 2x degrees plus 55 degrees, and these all equal to 540 degrees. So once I add these along with 55, I end up with 420 degrees plus 2x degrees. So subtract 420 from both sides. That gives me 120 degrees equals 2x degrees. Divide both sides by 2. So x degrees equals to 60 degrees. So all we need to do is find the number of sides, sub that into our sum rule formula, and add all the angles and solve for x. Okay, our last example is where we have a regular hexagon. So assuming that all these side lengths are the same, although my drawing doesn't really represent that, and we want to find A. So step 1, we need to find what n is. What's a hexagon? Therefore it's 6. Step 2, we want to find the sum of angles, so that's 180 n minus 2. And then we want to divide that by the total number of side length, which is n, or angles, because we know there's going to be 6 angles here as well. That's 180, 6 minus 2 over 6. It's 180 times 4 over 6, and that is, on the top we have 720 over 6, and that gives us 120 degrees. Therefore, A equals 120 degrees.